I'm Edwin Love. I'm going to talk to you about the power of examples. I have to apologise, my slides aren't the best slides I could have done. I did this all a little bit last minute. Right. Okay, so what I'm going to talk to you today about is a technique called modelling by examples. It's a technique for developing a rich, fully tested domain model using the language of the business. And I'm going to explain some of these terms in a minute. It combines aspects of behaviour-driven development and domain-driven design. And it was very much inspired by a talk I went to at PHP South Coast in 2017 by Kieran McNulty. I actually went to that. I went to that conference because I did one of those like and share our tweets and you might get a free ticket, and I did. So it just goes to show you sometimes win these things. Okay, so let's go through some terms. Behaviour-driven development. So I imagine some, hopefully all of you have come across behaviour-driven development. It's a bit like test-driven development, but different, where we're testing bigger things. We're testing behaviour rather than just units of code. Wikipedia says it's an agile software development process that encourages collaboration between developers, QA, and not technical or business participants in the software project. It's all about having stuff in a natural language. And it has this language called Gherkin. It's a plain text language with a little bit of extra structure designed to be easy to learn by non-programmers. So our Gherkin tests, they should be written by Scrum Masters, project managers, product owners, customers, clients, not the developers. Because what happens with this Gherkin code we write is then interpreted by, and there's all sorts of tools for all different languages. One I've used is called BHAT, which is a PHP version. I think every language has at least 3 BDD, Gherkin interpreters. It allows concise description of examples to illustrate business rules in most real-world domains. And the main aspects of Gherkin, we have features. A feature is something we want to do, which has got a clear, explicit title, and a little bit of narrative explaining what the behaviour is. This is completely ignored by the interpreter. This is just for us to read and understand. And the important part is the scenarios. These kind of roughly map to our acceptance criteria. And there's an important set of words we use: given, when, and then. So given are our preconditions, given A, given B, whatever. When is our action, so when I do this. And then describes the outcomes we need to see. And everything's written like this. It makes it kind of easy to parse what's going on. And here's an example. Feature, returns go to stock. I just grabbed this off the internet. I can't claim responsibility for it. So as a store owner, in order to keep track of stock, I want to add items back to stock when they're returned. So our scenario is refunded items should be returned to stock. So here are preconditions: given that a customer previously bought a keyboard from me, and I have 3 keyboards in stock. So you can, because it's rare you have one given and one then. If you've got more than one when, you need to question if what you're looking at is right, because we should only be looking at what happens in one instance. When they return the keyboard for a refund, then I should have 4. Oops, I didn't. That should read keyboards. I missed out the copy, changing that. Anyway, this is a strange stock control system. Notice how it doesn't make any reference to refunding the money or anything like that. This is just about returns going to stock. I'll get out of this slide before. Who knows what other mistakes I'll find. Okay, domain-driven design. Domain-driven design is a fairly mind-blowing thing. With a company I worked at before, we kind of decided to do as much domain-driven design as possible, and I had this book like this, which was fantastic at getting me off to sleep every night, but it took me months to read it. There's so much to it, and a lot of very in-depth stuff. But domain-driven design as an approach to software development for complex needs by connecting implementation to an evolving model. Premise of domain-driven design is the following: placing the primary focus on the core domain and domain logic. Basing complex designs on the model of a domain and initiating a creative collaboration between technical domain experts. Anyway, you can read that. It's all about managing complexity. It's all about a set of techniques for taking complex problems and making them manageable, making it easy, well, not so easy, but more manageable for us to kind of deal with them. Now, there are a lot of different concepts within domain-driven design, and the two core ones here are, and I'd say this is by far the most important one, is the idea of a ubiquitous language. Now, ubiquitous language is a language that is agreed, it's a shared understanding of terms. It's agreed amongst all the people working on the project. Now, I'm sure any of you who, have come across situations where the business uses one term and the developers use another term. I should have come up with a good example, especially when I'm talking about examples. But the business calls something a product, the developers call it a line item. And so when you're talking with the business, with that, you have to spend a bit of time translating or changing the terms you use. But if from the very start you agree on a language, and this language needs to be embedded in the business, because to expect them to adopt the language of the developer, what's the point? This is the way their industry works. We should be using their terms. And so by doing that, we reduce the cost of translation. And it means that it also helps with which is what I'm coming to, with our scenarios that we write. They're written using the business terms. So the business people can read these examples, read these scenarios, and understand them because they're using their language. The other thing is the idea of hexagonal architecture. Got a number of different names. Ports and adapters is another one. It's not specifically a domain-driven design concept, but I discovered it through learning, through experiments in domain-driven design. And it's all about having different layers which deal with different parts of the problem. And typically there's kind of various rules as to which layers can communicate with which layers, but I'm not going to go any further into that at the moment because it's not that relevant. Okay. Huh? Okay, I went backwards. So, examples. This is what I want to talk to you about. So examples versus rules. Often when we're given a problem to solve as developers, we're given a set of rules. And the business owners, sometimes business analysts have come up with, this is what I think, these are the rules behind what we've got here. And there are problems with this. They can be ambiguous. They often don't cover edge cases, corner cases, things like that. They're not covered there. They often hide many assumptions. There's a lot of things that within the business, within the industry, the people talking about, they just take these things for granted. That's just how these things happen. We don't know that as developers. This is not our domain yet. And they're abstractions. Now, abstractions are great in code. When it comes to testing, we don't want to be abstracting too much. It's quite dangerous. As a developer, I'm always looking for ways to abstract stuff out, look for stuff that I can make an abstraction of. But when it comes to writing scenarios and codes and tests, it's not how we want to do. So by contrast, examples are concrete. They're real-world scenarios. And the thing that's most important is they are objectively testable. You come up with a good example, you've got yourself a scenario, you've got yourself a test. You've worked these things out, and there you are. You've got a test case. So, an example, and I admit I stole this from the guy whose talk I'm basically ripping off here, so I didn't see the point in coming up with my own example. So we're starting a new budget airline flying between London and Manchester, and we're going to have a loyalty scheme. And the business comes to us and they say, okay, so for every £1 spent on a flight, it earns 1 point. 100 points can be redeemed for £10 on a future flight, and flights are taxed at 20%. There you go. There's the rules. Off you go. Now, that's ambiguous. As far as they're concerned, that's all we need to know. That's it. That's the rules from their point of view, and that's all they need to know. That's all we need to know. So just some questions. Do you earn points on the tax or just the base flight? Can you earn points when you are redeeming them? Can you redeem more than 100 points at a time if you have them? If you're redeeming points, what amount are you taxed on? Are points rounded up or down, partial? There's a lot of questions there. As developers, these things we start thinking about that straight away, automatically, and they're not there. Now, we could go back to the business and sort of do these things, but what I'm suggesting here is we do this by writing examples. And a lot of these things these are assumptions. This is how the industry does things. So let's get some examples. So if you pay in cash, it will cost £50 plus £10 tax, and you will earn 50 new points. That's a concrete example. We've gone to the business and said, okay, if I, and so this is a definite, really, something we can measure against. It's, if you pay entirely with points, it will cost 500 points plus £10 tax. 0 points. If you pay, so by going through, by talking to the business owners and saying, okay, you said this, I can see something that I'm not sure how it works, so I'll give you an example, and they tell you how it works. And so you've got, and each time we do this, we're writing our test suite. We're getting all this stuff done for us at the same time. So we then formulate our scenarios using our givens. And so you start simple. So given a flight costs £50, and you start by going through with the business and add realistic details. Given a flight from London to Manchester costs £50. And then you start to drill down and you start to really interrogate the stuff in there. And in the talk that I've taken from him, he goes through this in quite a lot of depth, but I don't have a lot of time. So given a flight with a flight number, XX100, which flies the LHR to MAN route. So in doing this, we've opened up loads of new concepts. So we've got this idea of a route. We've got this idea of airports with codes. We've got this idea of flights having particular codes. These are all things that, if we have an understanding of them, we build them into the logic. We build them into our core domain, and it means that our software much more closely models the way that the business actually works. And when things change, if they change, so we're more likely to be ready for them. Okay, so who should write these scenarios and when? So who? There's an idea in some agile circles of the three amigos. So the business expert, the customer, the person who knows all this stuff. A testing expert, ideally, a QA, BA, someone who's not necessarily writing the code, but who kind of understands the way the code is fitting together and how it will be working. And most importantly, well, no, they're all important, but the developer, because sometimes developers get left out of this stage. So yes, it is important. When? Just before the development, as late as possible before development, but when everyone who we need is there. And it's really important that it's before you start your sprint planning or estimation. You can't estimate until you've got these things. This is kind of defining what we're going to be doing. So until we know that, we can't really estimate. And we refine, as we kind of looked at in the last slide, you add realistic details. You actively seek terms from the domain. Okay, now this is where the hexagonal architecture part of it comes into it. If I'd had more time, I'd have drawn a nice diagram. Typically, the layer system you'd have is you have a UI layer at the top, then you have your domain model, your business domain, this is the important thing, and then underneath you have your infrastructure, which is how you interact with the outside world. So your database, your message queues, your mailers, your APIs, anything that you're communicating with that isn't your own business logic. For the purposes of testing, we want to be able to mock that, make it as simple as possible. It's something I like doing a lot anyway. But it's also, at this stage, we don't want to be thinking about, do I use an SQL database, a NoSQL database? Do I use all the, just use Redis objects or whatever? I don't even need to think about that. I just need to know I'm persisting some stuff and getting it back. And we do our modelling first, because once we've done our modelling, that might make those decisions easier to make. We might have we've got a better understanding of the problem, and we know whether we want to do various things, whether we need to use other APIs, whether we, et cetera, et cetera. And similarly with the UI, well, if we write tests against the UI, they're very slow. You've got to fire up a headless browser, and they're brittle. Typically, a UI test might be, when I click the button that says press me, then this happens. This isn't business logic. What our buttons say, what they do, where they are, that's not business logic. So UI they get in the way. It's implementation detail. When it comes to it, we want a subset of our UI tested. Of course, we need to have some smoke tests, make sure it's all working. But it's the domain level. That's what we really care about at this stage when we're modelling, when we're building this. That's what really matters. So we get rid of these. We mock these out. We get these out of the way because they're just a distraction. So our process. How do we turn this into software? So we agree upon our examples, we write our scenarios, Then we write the code hooks using the chosen BDD tool. So there's various ways I'm not going to go into that now because that's often specific. And of course the test will fail because there's nothing for them to test. Then you start writing the domain code to make it pass. And this is all, you're working inwards. So it's all part of the whole TDD red-green refractor cycle. Where we're writing a test, it fails, we make it pass. We go round and we make things better, and we go round and round and round. And you kind of work inwards. It takes a while to get to your first set of passing stuff because you've got quite a few layers to do in again before you come back out again. It's important that when you're writing your classes, your objects, your functions, you're using the terms from the ubiquitous language. That's really important because then when we're talking amongst ourselves, we're using the ubiquitous language. So when we talk to the business, we have the same terms in common. And once you get to smaller levels of the Unix code, then you're using more traditional unit tests, TDD, and then going back out again. So it's all this kind of start off with a behavior, define it, then make it work, and then move on to the next one. Don't forget to refactor in between each time. Unless you've done it with a load of mess. And now you can turn to your other layers. You can start making your infrastructure decisions. Do I want this? Do I want that? What does my UI look like? And there's a good chance that by having done some of this, you've got a better idea about your UI. If you just give the business rules to a UI designer and say, off you go, make this, there's a chance it won't be quite as good a fit as if they start doing it now. I've been talking quite a lot about the domain model. I thought I'd give it a bit more definition. The domain model is a conceptual representation of the business rules. And it's a bit of a kind of elusive thing. It's not like it exists in a lot of places, in a lot of ways. So it exists in your tests, it exists in your code, it exists in your documentation. Obviously, these things overlap. If you've got really good code and really good tests, you don't actually need any documentation, perhaps. It exists in your BDD scenarios, etc., etc. An interesting concept he brought up was the idea that your domain model exists in the developer's head, and it also exists in the business owner's head. And I really like this. It's nice to think of it as an algorithm. And if you pass your examples through the model in your head, through the model in their head, this is real examples, real numbers. It's a way of testing. Does my domain model match theirs? Is it doing the right thing? So I say to them, here's an example. They run it through, and this is what the outcome is. And so you think, well, with my current domain model in my head, when I run these numbers through, this happens. So my model is wrong. I need to change it. So it's an interesting way of getting through. Benefits and advantages. So for me, this is one of the biggest things. It involves the developers at the requirement analysis stage. I think this is far too often missed out. We're the best people to know how we solve problems. Bring us problems, not solution. A few years ago, I used to work for a site called My Builder, and we had it was all Kanban based. And when the business would give us a new card, they got something they wanted done, they were not allowed to say what they wanted us to do. They could write that on the back as a suggestion, but what they had to bring us was a problem they wanted solved. Because very often we'd look at this and say, well, actually, this and this is what we need to solve, and we'll fix this. Yes, I see your point. And so, as developers, we understand systems. We're problem solvers. It's what we do. I love this quote. People do not buy washing machines. They buy having their clothes clean. You might think you're buying a washing machine, but it's not. You're just buying the process. You're buying the thing. It's a bit like Mike's daughter's happiness. That's the outcome. That's what we're after. And it's important to keep our minds on this. It focuses our attention on use cases. Use cases are kind of what drives everything. It helps the development team to understand the core business domains, which is vital. If we understand what it is we're working on, we can work on it better. Encourages layered architecture, separation of concerns. It's always been something that part of solid principles and all those kind of, how to do software well. Separation of concerns is perhaps the most important concept, I think. And it speeds up our test suites because we are testing the right things in the right places. We're not having. I worked somewhere and we had a test suite took 40 minutes because most of our tests were through the UI. And yes, we knew that we were very confident that our site worked well, but yeah, it took a long time. Okay, so when to use it? When you have adequate access to stakeholders. This is important. We can't do this if we aren't able to interrogate the business properly. When the project is of significant scope. It does take a fair bit of time, this process. You could argue, as with most things like this, if you do this properly, in the long run, it's going to save you a lot of time. But you need to have a long run for that to be the case. And when the project will be around for long enough and will need to change. If it's something disposable, if it's something you're doing quick and dirty, a small side project, it's probably not worth it. And so if you do not have access to business experts, then you can't really use it. But that's something a situation we should never be in. Thank you. That's everything.